All right, number 15 and number 16 are both washer methods. To realize and notify this, I have my region, which is this section here, totally enclosed by the two curves, and I'm spinning this region around the x-axis. The reason it's a washer method is because of all of this gap, all of this missed area. When you have a washer method, you need to draw in two radii. You have your longer radius, which is the outer curve, the longer distance from the curve to the center of revolution, and then you have your shorter radius, which is the shorter curve, and the curve closer to the axis of revolution. The second you realize, after you've drawn, which most of you did not, that you have a washer method, what you need to do is write down pi integral big R squared minus little r squared dx. This will help you realize your structure and how you should denote your answer. Okay, so pi integral. Now when I do my limits, it's the left edge and the right edge in terms of x for which I'm sweeping these vertical lines. So I'm going to sweep from -3 to 0. Okay, big R is the top of my bigger radius to the axis of revolution. So the big R is the -x squared minus 2x plus 3, and then minus the axis of revolution, which is 0. That's the big radius there. Okay, now I got to subtract the little radius. So minus the little radius is the top of my little radius, which is my linear, minus the bottom of my little radius, which is the axis of revolution. This is big R, this is little r. I'm subtracting them, and I'm done. I put it in my calculator. You should get 108 pi over 5. Next, you need to draw these pictures. Okay, you need to shade the region we're spinning. I think we did this one in class. So I'm spinning this little pedal thing here. The thing that has changed is I'm spinning this one around the y-axis. Now that means everything's in terms of y. It also means my radii are drawn horizontally. So here's my big radius. It's the further curve to the axis of revolution. And then here's going to be my smaller radius. It's the closer curve to the axis of revolution. So it's a washer method because there's all this missing area. So the first thing I'm going to do is I'm going to do pi integral of big R squared minus little r squared dy. Now, it's in terms of y, that's very important. So when I start my limits, it's the y values that I'm sweeping these radii in. So it's y equals 0 to y equals 1. So 0 to 1. Okay, big R is the right edge of the bigger radius, the left edge of the bigger radius. Now the right edge is this function. Now we have to solve it for y. So the square root of y equals x. So the right edge is the square root of y minus the axis of revolution, which is 0, quantity squared. Okay, that's my big radius. Now my little radius, so minus the right edge, which is that curve, and then the axis of revolution. So the right edge here is y squared. The axis of revolution, quantity squared, dx. All right, I can plug that in my calculator to get my answer. You should get 3 pi over 10. In summary, this is a washer method, so you need to make sure you set it up as big R squared minus little r squared. It's a washer method because you're missing space there. This one was also a washer method. There's missing space, big R squared minus little r squared. 13 and 14 were not washer methods because the axis that I revolved around did not have any missing space between the shaded region and the axis. If you never drew your pictures, there's no way for you to visualize that. You need to draw your pictures. Once you draw your picture, you need to draw in these radii. I do it every single time. It's not because I have to, it's because it helps me prevent myself from making mistakes. You should always draw a picture. You should always draw your radii. Cross sections are a different animal. Cross sections, we're talking top to bottom of your base. There is no axis of revolution. So when I go right to left, it actually stops curve to curve. Okay? When you're talking about revolving things, you're not necessarily going curve to curve. Never in this problem do I do blue curve minus black curve. It's always curve to axis, curve to axis. So if you're talking about disc or washer method, it's curve to axis, not top to bottom or right to left.